So we'll see, we can keep writing, you'll see those terms will not matter, but you will see why. So this is, so let's say, so this is 0 now. So the first is, the requirement is f prime must be 0. Alright? So df, dx must be 0. Now the second term, the good thing about this is it doesn't depend on h, positive or negative, it's positive in both cases. So for this to be a maxima, what should be true about f double prime? F double prime should be negative, right?
No.
So f b square f dx square must be less than 0 for maximum. Now you can make exact, now the thing is that the next term doesn't matter because h is a small quantity, so this term will always be much larger than that. So that term can never cancel the effect of this. However, if f double prime is also 0, then what do?
You test points left and right.
Then you have to test for f triple prime. So f prime is 0, f double prime is also 0. But f triple prime is non-zero, then what does it mean? Sorry?
It converges?
What is this going to do to conversion?
I don't know.
What converges to what? So
Nothing.
what does that mean then? Is it a maxima or not? No, it's not. Because h triple prime again changes direction depending on both sides, right? And so it's not. It's neither a maxima nor a minima. However, if h triple prime is also 0, then what? Then it is a maxima or a minima depending upon the sign of h prime 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 prime, yes. And you can keep going. So that's the beauty of it. Once you know where it comes from, you can kind of make all these nice statements, right? Otherwise, in your mind, you kind of have to, I think most of you understand the graphical picture. But really, this is a more elegant way of understanding why maxima and minima requirements are, yes.
Yes, so you said that f prime has to be 0 because if you went in the positive direction for h, it needs to be a negative term.
Yes.
So f, okay.
Yeah. Because this doesn't have that property. Okay, now for it to be a minimum, if it's a minimum, which basically means you're in a valley, either side you go, the height has to go up. So that means this function has to be always positive. Which again means this still has to be 0. What should be true about f double prime? Positive. So the minimum requirements are df dx still has to be 0. The second order derivative. Okay. All right. So these are the requirements. Now we're going to use those requirements to figure out to solve our problem. Okay. Now I'm sure all of you probably knew this, but I'm not entirely sure how many of you actually knew the reasons for it. Now the good thing is, in the next class, we're going to talk about what happens when a function is of two unknowns, f(x), y. And then you will see things will suddenly become a little bit more tricky unless you understand the derivation, in which case it's still very simple. So that's how life always is. If you understand where everything comes from, everything is always simple. If you just try to learn something and you don't know where it really comes from, with a slight modification, you'll have no idea how to tackle it. Right? So that's why it's always good to know where things are coming from, so things stay simple. Okay, so that's our cost expression. So I'm going to bring this down, this out.
Are you okay?
Kind of. But I still lost my function.
You wrote it too low.
What?
That went underneath.
Do it.
Huh?
Now you have to
Keep
make
going.
Keep going, yeah.
Keep going.
you can't go.
Does it go to the floor?
Let's not lose the board.
Doesn't go anymore.
Okay.
Let's break the board, yeah.
No.
Oh no, it goes down. It goes below the board.
It does?
Yeah, just push that board down.
Are you sure?
Yes, I'm double sure.
If you have to pay, you pay for your break?
I'll pay you $1 if I'm wrong. No, dang it. Just kidding.
It's fine, you can see it. You can see your function if you pull it down.
Okay, so we are going to do it here.
What?
Okay, so that's a function we have to optimize. I can raise this all up a little bit more. So that's a function we want to optimize, right? Shh. Okay, so we take the derivative set it equal to 0. Not that difficult. I'm going to erase some little bit of this. Okay, so alpha stays alpha. Log becomes, derivative of log is simply 1 over that. So you get 1 over C max minus delta C minus 1 over C min minus delta C.
What are we doing, the derivative in terms of?
Derivative with respect to delta C. Right? And I suppose there has to be a minus there, right? Yeah, minus. Okay? Plus beta, the 2 cancels, and you're left with your C max minus delta C minus Cs. I suppose there's always a minus sign. Right? And we'll set this equal to 0. Right? So we take the derivative of the total cost, or the most likely cost. This term doesn't matter because it's a constant, so you don't have to worry about it. So you get alpha log of C max minus delta. If your derivative is 1 over C max minus delta C with a minus sign. Similarly, the next term is again the derivative and a minus. Yeah, basically just a derivative, right? Okay. So now we can solve this equation to figure out what delta C is. It's still not a trivial equation. It will turn out to be, what kind of equation will you finally get when you solve it, you think?
Quadratic.
Sorry? Be a cubic, right?
Damn.
So anyway, this is the equation we have to solve. It's not going to be too bad, don't worry. Anyway, we are just trying to figure out the concept. Okay, so we can combine these two terms. So you get C min minus C max, right? So alpha times C min minus C max divided by C max minus delta C times C min minus delta C equals to beta C max minus delta C minus Cs. Shh. Okay? Did I do what? Yeah, I forgot to make a negative sign. So I'm going to actually make this to be C max minus C. Okay? Alright, so even before solving anything, we are actually in a good place. So let's see why we're in a good place. First of all, as we already discussed right at the beginning, what if beta is infinity? What do you think will be the solution to this equation? If beta is infinity, this side must be 0. This entire thing in the parentheses must be 0. Right? Well, I mean, assuming that neither of these are actually 0, right? So delta C is not going to be equal to C min, delta C is not going to be C min. C min and C max are completely random quantities. We can solve for delta C and see what we get. So we'll solve, if this has to be 0, delta C must be equal to C max minus Cs, which is what we said right at the beginning, right? Which makes complete sense. That if the penalty function is really, really high, you design the system so that you are never going to go into the penalty phase. Does that make sense? Okay. What if alpha is infinity? So let's think about that. What that means is the cost of the scrubber is infinite. So what do? What do you make delta C? 0, right? You don't have a scrubber basically. So if alpha is infinity, what? Oh, because then there is no scrubber. But actually, you have actually a great, you actually make a great point. That you will see that that result will not come out of this equation. The answer is why. Sorry? No, because of the cost expression we have written. Our cost expression doesn't reduce to that. Our cost expression is alpha divided by C out minus C delta C. If delta C is 0, this cost is not going to 0. Right? Because the cost expression clearly breaks down in that region. Our cost expression is more valid when your outlet is really, really low concentration. Okay? And so whenever you're looking, when you're trying to solve problems, it's very nice to look at limiting cases. Limiting cases when something becomes infinity, something becomes 0. Because that tells you a lot about the physics. And sometimes when limiting cases are not working out, then it's also very interesting to figure out why they're not working out. You can see beta goes to infinity works out. Beta goes to, alpha goes to infinity, it doesn't work out. If alpha equals to 0, what do you think will happen? If alpha equals 0 means there is no penalty for scrubbing. Sorry? You get the same result as beta goes to infinity, because what it means is there's no penalty for scrubbing. You scrub as much as you need to. Which means you basically change by Cmax minus Cs. Right? Does that make sense? And which is again the result, because if alpha goes to 0, again this has to go to 0. So